I welcome you all for this video lecture on statistical quality control. So here in this video, let us see some basic control charts under statistical quality control. Content of this video are what is SQC, the control charts and its types, under that X bar chart, R chart, control chart for number of defects per unit and control chart for fraction defectives. First, let me introduce what is statistical quality control, that is SQC. So, for any businessman, it is necessary that his products should have a proper quality. If there is no quality, the customers will not buy his product, the sales will be less, then he will undergo a loss, right? Even if you are a customer, you will be preferring only the products that has best quality, right? So, for a businessman, it is necessary that he should have a quality products with him. That is, he should check over the quality of his product before he is sending it to the market. Okay, so for this he may use this statistical quality control. So what is this? It is nothing but the use of statistical methods in monitoring and maintaining the quality of products and services. The need for quality control arises because even after you are specifying some standards of quality, some variations occur in quality which are unavoidable. Such variations are of two types here, chance variations and assignable variations. What is the chance variations? That is due to chance, that are unavoidable and it can't be neglected, some errors that may occur unavoidably. Okay, so these are chance variations. Then assignable variations are the variations, that is fault made by the workers, or the machine may be fault, or some broken parts of the machine, then improper setting of the machine. So these are all unassignable variations which can be corrected, which can be brought into control. So these are called assignable variations. Here we will be using the control charts to use to avoid these assignable variations. Next one, what are control charts? A control chart is a graph. It is used to study how a process changes over time. Data are plotted in time order. A control chart always has three lines. So look at this graph, that is a model one. It has three lines, that is UCL, CL and LCL. The CL denotes the central line, that is for an average. Then UCL denotes the upper control limit and LCL denotes the lower control limit. So I'll be plotting the points given in our problem, and after joining these points, if any point lies outside this control limits, that is either beyond the upper control limit or lower control limit, it is indicated as a danger signal. So that is, there is an assignable error. You have to check over the quality. Then the manufacturer can concentrate on what is the problem over here, and he can check over the manufacturing methods or products likewise. So from this graph he can modify, he can standardize his quality. Now what are the types of control charts? So here the basically we have two types of control charts. First one is variables charts and the next one is attributes charts. What are variables charts? So variable charts are nothing but where we have measurements are used. That is, for example, if the manufacturing products are checked over the centimeter height, width, and how many liters are you can store here. So likewise, if it is in terms of measurements, then these comes under variables charts. Attributes charts are nothing but which is not amenable by this measurements. Instead, we'll be checking, for example, whether we can broke or unbroke the plastics, or for in case of bottles, whether there is a hole or not. So likewise, those things cannot be measured by proper measurements. So we'll be using this attributes charts. Under variables charts, we have two types, R chart and X bar chart. And under attributes charts, we have two types, P chart and C chart. The C chart and P chart are based on the number of defectives or fraction of defectives per unit. Variable charts are based on the average value and range value of the given items, given data. Let us start with X bar chart. This X bar chart is used to show the quality averages of the samples drawn from a given process. You know what is meant by X bar? It denotes the average or mean value, right? Now let me give an example. With this we can understand how to draw a X bar chart. For example, that is, a factory produces 50 cylinders per hour. Samples of 10 cylinders are taken at random from the production of every hour and the diameters of cylinders are measured. Draw X bar and R chart and decide whether the process is under control or not. So here we are going to see both X bar chart and R chart in a single problem. So what is R chart is nothing but instead of average we will be using the range of the given data. So I will show you how to calculate this R by R chart and X bar chart. So you have to decide whether the process is under control or not. The table values are given here. For n is equal to 4, A2 is 0.73, D3 0, D4 is 2.28. It is given in the problem. And the data is given, that is for 10 samples. We have 4 different samples, that is n equal to 4. For each sample number we have 4 different types of data. So likewise we have 10 numbers, right? So this is the question given. Now how to solve this question? With this table you are adding 3 more columns, okay? So in the total what you are doing is you are adding the 4 values. For the first sample I am adding the 4 numbers that comes under the column total, okay? Then sample mean is I will be dividing this total divided by 4 because here n value is 4. You are considering 4 values, right? So 960 divided by 4. Likewise 910 divided by 4. 930 divided by 4. So likewise we will be filling down the next column. And the last column is sample range. So what is range? So I think you have learnt already. Even not, I will teach you now. So that is here range means you will be finding the difference between the highest value and the lowest value. So among the 4 values here in the first sample number, what is the highest value? 250. What is the lowest value? 230. What is the difference between them? That is 20. Okay, the highest value minus lowest value. If you want clarification further, look at the second one. In the second sample number, what is the highest value? Say it is 242. The lowest value is 218. The difference between them is 24. Okay, so you are finding the difference between the highest value and the lowest value and you are filling down the last column. Then find the total of the 2 columns, sample mean and sample average. Okay, then so next here is the calculation for X double bar and R bar. X double bar is nothing but again you are finding the average of X bar. So that is X double bar. So that is given by summation X bar divided by M. Summation X bar we have already calculated in the table, that is 2345.75, and M is the sample number. How many data you have added? 10. So divided by 10. So your answer is 234.75. So likewise R bar is equal to summation R by M. That is total of R 196 divided by how many sample numbers are there? 10. So answer is 19.6. Next you will be using this table to find your that is for your for calculating X bar in the formula. So just look at the value of A2, D3 and D4. It is already given in the problem, but as well you can check it from this table. Sample number size is 4 for this problem, right? So now see what is the value of A2? It is 0.73. You will be using further in this calculation to calculate your control limits. Then what is the value of D3? It is 0 for the sample size 4, and D4 value is 2.28. You can note down these values. You will be using these values in the further calculations. Okay, next we are finding the control limits of X bar chart. The first one is central line, CL you have to calculate. So that is nothing but your X double bar, okay, average value. That is already you have calculated. So 234.75. Then UCL, upper control limit. So upper control limit is given by the formula X double bar plus A2 into R bar. Okay, X double bar you know, A2 I have shown you in the table now. Then into R bar 19.6. So if you are simplifying this, you will be getting your answer as 249.06. So likewise, what is LCL, lower control limit? The same formula, but you will be replacing plus sign by minus sign. Okay, so the same values, instead of adding or subtracting here, so you are getting your answer as 220.72. Okay, so next one, you are drawing a X bar chart. Okay, what are the things you have to do is you have to draw 3 lines, CL, UCL and LCL. Okay, have marked the points now. So 249 point something, that is your upper control limit, then central line average, then lower control limit is 220 point value, right? And these points are you are plotting from the data given. Okay, the average X bar value you have to plot on this graph and join the points. Now look at this graph. So here there is no point lies outside this control limit. So therefore the process is under the state of control. Okay. So likewise you can give your conclusion. Next, for the same problem, how to draw the R chart. So you have to find the control limits of R chart. What is the central line here is R bar. R bar is equal to 19.6, which we have calculated already. Then UCL here is given by the formula D4 R bar. So D4 I have shown you in the table. So the value is 2.28 into R bar 19.6. So your answer is 45.5. Then LCL is D3 into R bar. So D3 value is 0. I have shown you in the table, right? So 0 into any number is 0. So now let us mark these points in your R chart. So here draw the line CL, LCL and UCL. Okay, LCL is 0. So we are considering the x-axis. Then plot the points. Here you will be plotting the points that you have calculated, no, the sample range. That points will be plotted over here. Then join those points. Here is also there is no point lies outside this control lines. Therefore, the process is under the state of control. Okay. So we have seen both X bar chart and R chart for the same problem. Almost you will be working out both the charts together. You won't work out R chart alone. If in a problem you are asked to draw both X bar chart and R chart, it is better you can draw R chart first because the calculation is very simple. If it is under the control, that is if no point lies outside the control limits, then you can go for X bar chart, or otherwise you can stop over here. If it is not under the state of control, you can stop and say it is not necessary to check with X bar chart. Under R chart you have to check over because there is a danger signal. You can conclude like that. Okay. So then C chart. So C chart is the chart for number of defectives. That is, it comes under attributes charts. Okay. So here it is used for discrete defects when there can be more than one defect per unit. If there is more than one defect per unit, you can use the C chart. It is based on number of defects in the unit. Okay. Now, for example, the number of weekly customer complaints are monitored in a large hotel using a C chart. Okay. Now, develop 3 sigma control limits using the data given below. So, what is the data given? See here. So, week, first week, second week. So, likewise, till 20 weeks the data is given, and the number of complaints registered are in the first week 3 complaints, second week 2 complaints. It likewise data is given, and the number of total complaints is given as 44. Now, in order to find a solution, first you have to calculate the average number of complaints per week. That is your C bar. Okay. So it is given by, what is the total? 44 divided by how many weeks are considered? 20. So answer is 2.2. So C bar is equal to 2.2. Next, find your upper control limit. Here the formula is, note the formula here. It is C bar plus 3 into square root of C bar. So it is enough if you know the value of C bar to calculate this upper control limit and lower control limit. Now substitute the value of C bar, and if you are simplifying, you will get your answer as 6.65. So next, similarly, LCL, lower control limit, is given by the same formula, but you will be replacing plus sign by minus sign. So C bar minus 3 into square root of C bar. Substitute the value of C bar again. So here you are getting the value as negative, that is minus 2.25. So in case of number of defectives, it is not possible to get a negative value, right? So I will be considering your lower control limit as 0. Okay, if it comes negative, you have to take your control limit as 0 always. Okay, then now draw the chart. So here the points plotted here are number of defectives, number of customer complaints. Okay, here that points has to be marked on this graph for those 20 weeks. Then see the lines are drawn. The upper control line, okay, the lower control line is considered as 0, and the average is 2.2. See, all the points are coming within the control limits. Therefore, the process is under the state of control. Okay, there is no any problem. Okay, so likewise you can give a conclusion for the problem. Next one, the last one is P chart. Okay, so P chart is used for quality characteristics that are discrete and involves yes or no or good or bad decisions. Okay, this P chart, how the problem will be given is, instead of number of defectives, the fraction of defectives will be given in the problem. So in that case, you can use your P chart. Okay, here look at this example. A production manager of a BKT tire company has inspected the number of defective tires in 5 random samples with 20 tires in each sample. The table below shows the number of defective tires in each sample of 20 tires. Calculate the control limits. Okay. You see, here the problem is given. There are 20 sample numbers given. Number of defective tires are given. Number of samples observed and fraction defectives. Okay, fraction defectives are given in the problem. Now, what are the calculation required or to give the solution of this problem? As usual, you have to calculate 3 line points, that is CL, UCL and LCL. First for CL, the formula is P bar. Okay, that is total number of defective tires divided by total number of observations. The total is already given in your question. Okay, so 40 divided by 400. So your answer is 0.1. Then you have to calculate what is sigma p. So it is required to be substituted in finding UCL and LCL. So you are calculating sigma p. So that is given by p bar into square root of p bar into 1 minus p bar divided by n. Here n is the number of samples 20 and p bar you have calculated here. Substitute the value of p bar and you are getting your answer as 0.067. Then using this p bar and sigma p value, you can find your upper control limit and lower control limit. So what is your upper control limit? P bar plus 3 into sigma p. Substitute the value of p bar and sigma p. Then you are getting your answer as 0.301. Similarly, find your LCL. So here the same thing, that is p bar minus 3 into sigma p. So now substitute the same values, you are getting your answer as minus 0.101. I told you already your control limit will not be negative. So therefore you have to consider it as 0. Okay, so LCL is equal to 0, UCL is equal to 0.301 and P bar central line is equal to 0.1. Okay, now plot the points on the graph. Okay, so here what the points will be plotting here is the fraction defectives. It is mentioned in the problem, right, in the table. So you have to plot the points of fraction defectives for the first sample, second sample. Likewise, you will be plotting the fraction defectives and join those points by straight lines. So here you have drawn what is the upper control line, then lower control line is 0, then the central line is 0.1. So here also there is no point lies outside the control limits. Therefore, the process is under the state of control. So likewise, all these charts can be used to check your quality. That is, you can check the quality of the product you are manufacturing. Okay. So now to summarize, what are the things we have seen here? We have understood the meaning of statistical quality control and the control chart types, that is X bar chart, R chart, then C chart and P chart. Okay, thank you all. Thank you for your patient listening. Thank you.